routine tests are carried out on each job and can be classified as follows. 1. Measurement of winding resistance. 2. Measurement of insulation resistance. 3. Separate source voltage withstand test. High voltage tests on HV and LV. 4. Induced over voltage withstand test, DVTF test. 5. Measurement of voltage ratio. 6. Measurement of no load loss and current. 7. Measurement of load loss and impedance, efficiency and regulation. 8. Vector group verification. 9. Oil PDV test. Click each tab for more information. This test measures the resistance of the HV and LV winding. The values of resistance should be balanced for all three phases and should match the designed values. Equipment used is digital resistance meter. Measures the insulation resistance of HV and LV windings with respect to earth, body and between LV and HV winding. Insulation tester or measure is used. Recommended values are 2000 m ohms for HV and 500 m ohms for LV. This test checks the insulation property between primary to earth, secondary to earth and between primary and secondary. HV high voltage test. LV winding connected together and earthed. HV winding connected together and given 28 kV for 11 kV transformer for 1 minute. LV high voltage test. HV winding connected together and earthed. LV winding connected together and given 3 kV for 1 minute. Equipment used is high voltage tester, 100 kV and 3 kV. This test checks the inter-turn insulation. For a 11 kV upon 433V transformer, 866 volts are applied at the 433V winding with the help of a generator for 1 minute. This induces 22 kV on 11 kV side. The frequency of the 866V supply is also increased to 100 Hz. Equipment used is motor generator set. This test measures the voltage ratio as per the customer's requirement. The voltage ratio is equal to the turns ratio in a transformer. V1 upon V2 equals to N1 upon N2. Using this principle, the turns ratio is measured with the help of a turns ratio meter. If it is correct, then the voltage ratio is assumed to be correct. Equipment used here is turns ratio meter. The iron losses and no load current are measured in the test. The 433V winding is charged at 433V supply and the 11 kV winding is left open. The power consumed by the transformer at no load is the no load loss in the transformer. Effect of actual frequency must be taken into account. Equipment used are watt meters or power analyzer. This test measures the power consumed by the transformer when the 433V winding is short-circuited and the rated current is passed through the 11 kV winding. This test verifies the DYN11 vector group of a distribution transformer. Here, vector group means angular displacement between HV and LV of same phasor. For example, capital R and small r. Equipment used here is voltmeter. Oil breakdown voltage is checked as per IS-335. This includes 100 mm length into 70 mm breadth into 80 mm height glass pot, 500 milliliter oil sample, spherical electrodes with gap of 2.5 mm. Recommended value is 60 kV. Type tests are carried out only on one transformer of the lot. They are done to check the design and process parameters. They include all routine tests. Additionally, following tests are included in type tests. 1. Lightning impulse test. 2. Temperature rise test. Lightning impulse test. All the dielectric tests check the insulation level of the job. Impulse generator is used to produce the specified voltage impulse wave of 1.2 upon 50 microseconds wave. One impulse of a reduced voltage between 50 to 75% of the full test voltage and subsequent 3 impulses at full voltage. For a 3-phase transformer, impulse is carried out on all 3 phases in succession. The voltage is applied on each of the line terminal in succession, keeping the other terminals earthed. The current and voltage wave shapes are recorded on the oscilloscope, and any distortion in the wave shape is the criteria for failure. Special tests can be categorized as follows: additional impulse test, short circuit test, measurement of zero-phase sequence impedance test, measurement of acoustic noise level, measurement of harmonics of the no-load current, magnetic balance test. Short circuit withstand ability test. This test measures the ability of the transformer to withstand the mechanical and thermal stresses caused by the external short circuit. HV terminals are connected to the supply bus of the testing plant. The LV is short-circuited. The testing plant parameters are such adjusted to give the rated short-circuit current. Supply is made on and closed after specified duration of short circuit. The record of current waveform is noted. There should not be any mechanical distortion prior to the transformer during this test. Similarly, no waveform distortion. The transformer should also withstand the routine tests after the short circuit test. The reactance of the winding measured before and after the SC test should not vary beyond the limits stated in the IS 2026.